This is a video tutorial for tutorial 4 question 5. Question 5 tells us that the function g is defined by x maps on to e to the mod x minus 1 for all real numbers and all positive real numbers. We have to determine whether g inverse exists. So if it does not exist, we need to find the largest domain of g such that it would exist. So how do we determine whether an inverse function exists? An inverse exists if and only if the function is 1, 1. How do we determine if a function is 1, 1? We draw the graph and conduct the horizontal line test. So here I'm going to draw the graph y equals to e to the power of modulus x minus 1. And I'm going to draw that, let me redefine that. I'm going to draw that only for x greater than 0, for positive real numbers, e to the power of absolute value x minus 1. So this is what our function f of x, or g of x rather, looks like. Yeah, now I can call it g of x. So we can see from this graph that it clearly is not a 1, 1 function, because if I have some arbitrary line, say y equals to 2, that line will intersect it in two places. And it's not just 2, I can take this line up and down anywhere between 1 and e, is this value I think, it will have 2 points of intersection. So what should we say? We should say g inverse, because the line y equals 2, now choose something between 1 and e, so 2 is a fairly good choice here, so we can use y equals to 2. Because the line y equals to 2 intersects the graph of y equals to g of x twice, g is not a 1, 1 function. Therefore, g inverse does not exist. So that answers the first part. So now we look at the graph again, and we have to try and determine the largest domain of g such that g inverse exists. Now you can see the problem. The largest domain, well, okay, we kind of want this whole chunk is fine. It's just this turning point here causes all sorts of problems. It's this little tick part that means that it's not a 1, 1 function. So what we need to do is we need to restrict the domain of g so that it excludes this little uptick part here. So if we look at this, we can see that the turning point is going to be 1, 1. You can use your GC to determine that as well. So the turning point's 1, 1. That means that to get rid of this little tick here, we have to exclude numbers between 0 and 1. Now we can include 1 because there's only one value there, but we can't go any past it. We can't go past it at all. So what should we say? Well, we can say the turning point of g is 1, 1, restricting g to the domain (1 to infinity) means g would be 1, 1, and thus g inverse would exist. Therefore, maximal domain equals to 1 infinity. And that brings us to the end of question 5.